Welcome to what I think will be the final part of the series. And the first thing I'll do here is I'll adjust the values in our pandemic function a little. I'm going to set this to 5,000 people, size 3, speed appears to be fine. So do these three, no, recovery time, we're going to change that. I'm going to set this to 100. Remember, I set this to this large number to make sure that the infection was going, infections were going on, and probability of death, I'm going to reintroduce that. I'm going to set that to 0.005. And let's run this. And now, of course, the world got lucky because nobody got infected quickly enough, because the recovery time was short. Okay, maybe 200. Okay, so here's our patient 0. They just infected someone, and now I think is the time where mass infections now occur. The frame rate is still pretty high, but thanks to the fact that people are also recovering, the frame rate will now not drop too low. So it's dropping now, but remember, when points turn blue again, the code does not have to go through all of these people and run all the additional checks on the distances to the healthy people. And yeah, now the pandemic is working. We can also see that people are dying because up here the density of the points is decreasing, whereas down here it's roughly the same as it was in the beginning of the pandemic. And yeah, we could now wait for this animation to finish, but then we wouldn't have anything to look at. So let's introduce a track record of how the pandemic has evolved. Okay, and to do that, we'll define a new function. We have our run function, and down here we'll now create a function that I'll simply call keep track. So this is now going to keep track of the state of the pandemic. I'll first store all the health states of people, so p.state for p in self.people. Now I'll count the number of healthy people, so states.count healthy, the number of infected people. Okay, we don't really need the number of healthy people. That's boring. Let's just go for infections and fatalities. So states.count infected, and the number of deceased people and dead is equal to states.count dead. Now we'll create a little record, self.record. So we have a new property to our pandemic class. We'll create this right up here after the grid. Yeah, this is just self.record and empty list. And you know what? Let's also create a Boolean for whether or not the pandemic is over or not. So self.over is false in the beginning. And now let's go back to the keep track function here. Keep track. So we'll just append to the track record a list of the number of infected people and the number of dead people. And then we'll say if n.infected is equal to 0. Well, if that is the case, the pandemic is over because, if there aren't any people that are currently have the virus can no longer spread, or the bacteria, or whatever the disease is, and then the pandemic will only last as long until everybody is immune or has recovered and is no longer immune. It doesn't really matter if the virus won't spread anymore. The pandemic is over effectively. Okay, now that we have the track record, let's say that we want to have a little summary at the end of the pandemic. So let's summarize this, and we do that by creating a summarize function. And here we'll now have our infected people. So infected is R0 for R in self.record. So remember, self.record is a list of lists. So for each period in the pandemic, we have a list that stores the number of infected people and the number of dead people. And now we're just unpacking that list, so to speak. So now we have R0. That's not supposed to be like that. R0, and here R1 for R in self.record. record. Okay. And now we'll just try to visualize this. So we'll import the classic module, classic library for creating plots in Python, which is matplotlib. So from matplotlib import pyplot. Now let's go back down here to where we were coding. And let's create a new plot. So let's do that. Let's create a figure and an axes object by using pyplot.subplots. And once we've done that, we'll now add to this axis thing a plot here. And we must add an x variable and a y variable. So on the vertical axis, the y-axis, we'll have the number of infected people and the number of dead people. And on the horizontal axis, the x-axis, we'll have a simple time index, okay? So let's create this. Time index is equal to, it's a range that starts at 1, so the pandemic starts in a period 1, and then it goes until, well, the length of self.record. And because we're not starting at 0 here, we must add +1 here for this to add up, okay? Okay, so x.plot, we'll now take our time index and the number of infected people, and we'll choose a color, and we'll set that to red. And then, well, we can set a label for the x-axis, so we'll just say period here, time period, and then x.set y label, this is people currently infected. What's happening here? Currently infected, and here also color is equal to red. Okay, now where do we include this? So with the Pygame loop, we can now say and not pandemic over. This means that once the pandemic is over, the animation window will actually close and the matplotlib window will pop up. And well, when is the matplotlib window going to appear? Well, it will appear if we specify the following after the Pygame loop pandemic.summarize, and then we'll have our little summary. So create summary plot of pandemic. And remember, pyplots only appear if you really tell them to appear, so pyplot.show. And I think that should really be it. And let's not go for a super large pandemic. Let's go for a small one. Let's run this. Now there's, okay, the pandemic is, I think it's already over. But our animation keeps on going even though there's nobody infected. So maybe this is because we haven't really kept track. But you noticed there was a little summary plot at the end. And, well, I really didn't keep track because this is what I'll have to do after the run function here, run pandemic, and keep track. So here I'll say pandemic.keep track. Now this should work. So yeah, the pandemic was over fairly quickly. So let's run this once more. Again, bad luck. You know what? Let's just set the infectious distance to something super high to make sure that people get infected in no time. So now you can see the pandemic spreading. Takes no time. Now everybody recovers and the pandemic's over. And there we go. Here's our summary plot that says that we just had one quick wave of infections and then everything cooled down. And after some 600-700 periods, everything was over. Now let's add to this plot the number of fatalities. And let's use this second axis here, or this right-hand side of the plot, to have a second y-axis here that tracks the number of dead people. Okay, how do we do that? we'll go into our summarize function and create a second y-axis. Okay, so we can do that. I'm just going to call this x2 by using the twin x function. So x2.plot. Now again, let's use the time index. And let's use the number of dead people. Color, we'll set that to black. x2.set y label. Let's give it a name. And let's say cumulative death count. And we'll color, set that to black. Gonna run the up. That's an error. What's happening here? Yep, just missed equal sign. Now this is working. Pandemic spreads. Now everybody recovers. Come on, pandemic is over, and we now see that there's the cumulative death count. So maybe some of you don't find this, not really informative, because you're like, of course, it's just going to increase. So let's, instead of plotting the cumulative death count, let's visualize the number of new fatalities. So the number of people that have just died in that particular period. Okay? So let's exit out of this. And yeah, how do we do that? Well, so instead of just looking at the total number of fatalities, let's create something that I'll call newly dead. Okay? And here we'll now compute a, well, not yet. So here we'll set, okay, in the first period, there is nobody that has already died. So we can specify a list with a single entry, and that's just 0. Okay? Now, for I in range 1 until the length of dead. So we're not traversing this list here, but we're not starting at the first, but the second list entry. And now we'll append to newly dead. Append, and what are we appending? We are appending dead at index position I minus dead at index position I minus 1. So we are just really computing the difference here. Now we can visualize this, and this is new fatalities instead of people that have died in total. Okay, let's have a look at whether or not this works. Our super quick pandemic, the recovery, and there we go. This is all good and fine, but notice how the numbers really fluctuate a lot. It just keeps on going up and down a lot. And here it's important that we smooth this. And we can smooth this by using a simple moving average. Now, a moving average really just says, instead of looking at the raw data as they are, so, whatever number of people died today, let's look at an average over, maybe the preceding 3 days, the current day, and the 3 days after it. So that's a 7-day moving average. So we compute this moving average, and this will then make for a smoother line that's, a bit better on the eye, and it's more easy to interpret this. Okay, let's code this. So we'll first have to have a moving average function that can take a list of numerical values and compute a moving average of that. And there's probably a bunch of libraries out there that can do that, and there's probably people that can code better functions than I do. But what worked for me was, a moving average function where I have a parameter k. I'm going to set that to 7, for example, which works as follows. So I have this is not a 1, this is an L, so we have a list L. And now let's have a average list, and this is what we would like to return in the very end. But how does that work? Well, so the first couple of values, there is not really a moving average that we can compute, because remember, for observation t, so at time t, to compute a moving average on that day, we would have to have observations in the past. But at the very beginning of the list, there are no observations that are in the past. So yeah, these are missing values or simply zeros because, well, we might argue that in the beginning of the pandemic, there are not a lot of people that are dead. So here we can just say 0 for I in range k half. So, before a particular date, everything's just 0 because, no one's there that has already died. And then for I in range, and now we're starting at k half until the length of L minus k half. Now we create a little sublist, L I minus k half. So now we're just subtracting, or, not subtracting, extracting that little part of the list, which is today's observation, the 3 days before it, and the 3 days after it. So I minus k half, if we use the double division operator here, k half of 7 will then be not 3.5, but 3. So I minus k half until I plus k half. And then because of, Python indexing, we must also use +1 here. And then we'll just append to our average, append the sum of sub divided by the length of the sub. So this is really just, how you compute an average. And then we return average, but we must also add to the end of average what we had at the beginning, because at the end of the list, we can again not compute a moving average. And now we can use this function down here where we summarize the pandemic. So keep track, summarize. Now here you'll say that newly dead is equal to a moving average of newly dead. And I think that 20 might work quite nicely. So here we'll now say 20 period moving average of fatalities. And let's run this. We get an error. Yep, 0. Okay, that's a pretty simple fix. You will probably have seen this while I was coding this. 0 for I in, and now down here, same thing. Now, let's see. The pandemic spreads. There we go. People start to recover. There we go. And now, instead of this super volatile curve that was just fluctuating up and down all the time, we now have a somewhat smoother curve. But I made an error here. I made a mistake. I mixed up the two axis labels, so it now says 20 period moving average of fatalities, where it should say currently infected people, and here it still says new fatalities. So that's, I guess, the last thing that we'll have to fix, and then we're all done. So this goes down here, and up here it says currently infected people. Okay. Final run for today. Everything is working. People are recovering. And now we can see a nice diagram of our pandemic. There's a rapid increase. Then it kind of stagnates a little. And then comes another second wave. And this is also where a lot of people die. So at most, there's 2.5 people dying in one period. Remember, it's a moving average. And then everything drops down. I said this was the last pandemic, but come on, let's have a look at one more where we have 10,000 people in there. And I'm going to set the recovery time a little shorter. Let's see whether that works. Well, maybe I'm going to keep this to 200, but reduce this. Make this 10. Okay? So, there we go. The pandemic now spreads. A lot of people are infected. Now the frame rate drops. We need those recoveries to set in for the frame rate to recover a little. Yeah, that no pun intended. So now people are recovering down here. The frame rate is already pretty low, so you'll see there is still room for improvement here. People are also dying down here, but it's not too bad, I think. But the frame rate is too low. I'm terribly sorry for that. So I'm going to have to exit out of this, set this to maybe 100, run this again. Now the recovery should set in earlier. And let's just watch this unfold. And I think it's just so cool to see how this is just like growing, like, it's like a tumor in tissue or something like that, or like water that's spreading through, that's like being poured on some soil or something. So interesting to look at this, some liquid that's, running through the cracks of, ground or whatever. And okay, let's see whether we can go for a bunch of different waves here. The problem is that the immunity time is set to a rather high value. So I don't think that a lot of people, so some people have lost their immunity, but these people up here, the last couple of infected people, will not reach them in time to reinfect them. So we just have one gigantic wave of infections. Okay, there's always one more run. So let's set this to maybe only 300. And let's see whether that does the trick. Okay, we are starting in the bottom right corner. People are now recovering from that. Let's see at what point they start losing their immunity. So there's one white dot down here that did not get infected or that already recovered. I'm not too sure which it is. But actually a person that was never infected. Okay, now there's more white dots popping up here and there. And now I think is where, people start to lose their immunity on a larger scale. But again, I think because we started in the bottom right-hand corner, these folks up there won't reach it on there. So we still have only one wave, but now it's up to you to play around with the parameters to study whether you can make for realistically looking graphs of infections and things that you can see on the news related to coronavirus or not, or some other virus. You might be watching this years in the future when the world is, suffering from yet another pandemic. I don't know. I hope you enjoyed this project. This is now, I think, the very last part of this series of videos. You can come up with a bunch of ideas to, really develop this further. You could introduce vaccination programs. So you could, for example, have healthy people directly go to the immune state without having them to go through the infection. You could introduce things like compulsory masks. So say the pandemic has reached a certain number of infections, and then the government introduces a new policy of social distancing and mask wearing, which is, maybe reducing the probability of catching the virus or decreasing the distance at which people can get infected. You could introduce something like summer and winter time and then say that the virus is more active in one of those two seasons. So these could just be two, or like one Boolean specifying whether or not it's the time where the virus is more active, and at that time the infectious distance is greater or the probability of catching the virus is greater. Maybe even the probability of death is greater, something like that. You can really play around with this, and you could introduce a physical barrier somewhere in our Pygame animation that works like a border, and then you can check whether borders are good at, making sure that not the entire population gets infected by the virus. Things like that. Play around, have fun, come up with creative ideas, and get coding. Thank you very much for watching.